Back a few years ago, the Kepler telescope identified a star about 1,500 light years from the Earth, such that starlight dimmed not just a 0.5% or 1%, but by 15%. This is humongous. This had never, ever happened before. And a few years later, it damped once again by a factor of 22%. This is unheard of. Whoever thought that starlight could diminish by that much by an object which seemed to be, well, not natural. In some sense, maybe it was artificial because it didn't seem to be shaped like a circle. However, this object may not be round, and its orbit is highly irregular. Well, this sent astronomers scrambling to the blackboard, trying to figure out what the hell is this object. Second of all, they look for alien structures, megastructures. If aliens are really out there and they're advanced, they may be able to assemble an object perhaps as big as a planet, or they might be able to play with natural phenomena. In other words, starlight would be affected by their very presence. Now, astronomers are scratching their head. They're wondering what the hell could be causing this. And starlight does indeed dim, just like the Kepler telescope has verified. We have an object that is apparently, who knows for sure, exhibiting Type 2 technology, specifically a Dyson sphere. Now, what is a Dyson sphere? Freeman Dyson, physicist at Princeton, knew that there was this ranking of intelligent civilizations by energy output. And he reasoned that if there really was a Type 2 civilization, its energy consumption would be so great that they would literally control the energy output of the entire star. Now, how can you do that? You could do that by building a shell around the mother star, which then absorbs all the starlight from the star. So a Type 2 civilization would have a signature. They would be able to play with starlight. So that light from the mother star would flicker. It would be perhaps irregular, or perhaps the star would simply disappear totally. Well, eventually the Dyson sphere itself would heat up by the second law of thermodynamics, and it would get hot. So it would start to glow in the infrared, an alien structure, a structure built by a civilization perhaps thousands of years ahead of us. So if a civilization had the power to create some kind of sphere, some kind of solar collecting device comparable to the size of Jupiter and beyond, then we are talking about a Type 2 or a Type 3 civilization. And so scientists begin to say, oh my God, what could possibly rival the energy of a Type 2 or a Type 3 civilization? Now, there are exotic possibilities. Since we are dealing with an unprecedented phenomenon, we have to consider them. So we have a long ways to go before we can begin to say that we've analyzed even a significant fraction of the number of stars in the Milky Way galaxy. And what do we look for? We look for any signs of regularity. I mean, after all, the aliens don't speak English. The aliens don't use the same mathematical symbols as us. So how would we recognize a signal from an alien civilization if it were staring at us in the face? It would be regular rather than random. Next, what do we do about it? Do we call them on the telephone and say, hey, here we are, brothers in the galaxy? Nope, it doesn't work that way. It would take 3,000 years for a message to go from here to there and back. What happens if they don't use radio at all? For example, let's say they use laser beams. If they use laser beams, they would be collimated. They would be in the optical frequencies rather than the radio frequencies. And basically, we wouldn't know. We wouldn't even know that we were staring at a message right in front of our eyes because we would not have the instruments that are focused in on the optical frequencies, that are focused in on the characteristics of laser light. And so simply looking for signs of intelligent life by analyzing its radio signals is kind of pathetic.